Welcome to today's lesson on definite integration. So last lesson we learned how to integrate, and integration is actually used to find the area underneath a curve. So you can see on this diagram here you're given a curve, and when you integrate you actually give the answer of this blue space here, the space trapped between the curve and the x-axis. So last lesson's integration was actually called indefinite integration. And it's when you integrate, you have to remember to put this plus c on the end, which represented a constant that we were unsure of the value. So indefinite integration has no specific values given to you. You just have to put that plus c on the end. However, today we're going to look at definite integration. So a definite integral has a start and an end value, which we call limits. And they're often represented by A and B, which you can see here on my graph. So you can see we're working out a specific section underneath the curve to the x-axis here. And a definite integral can be evaluated to give a numerical answer, but be warned, this can often be a fraction answer. So for a definite integral, our integral has our limits on it. So that's how you know it's a definite integral. You integrate it exactly the same way, but you can see you put it in these square brackets here and you put your limits on either end. Now, we use these square brackets for a reason. They actually mean substitute and subtract. So what we have to do, everywhere where you have an x, you substitute your first limit in to create a function, as we call it. Then we have to subtract the second limit substituted into everywhere where you have an x. So we substitute both limits in one at a time and we subtract those two answers. This is actually used to shorten workings, which we're going to see in our examples now. So example 1, you can see the integral sign here has our limits on the top and the bottom. So our limits are 2 and 1, and we're integrating 2x. So remember, we need to open a square bracket, so not a curved bracket. Remember, when we integrate, we increase the power by 1 and then divide by it. Remember, this power here that we can't see is a 1. So here we're going to go 2x, increase it to a squared, and divide by 2. Close it with a square bracket, and then your upper limit goes on the top here and your lower limit below. So we've got 2x squared over 2. Just like before when we were integrating, this can cancel down to make it a bit easier for us. So 2 divided by 2 cancels, which leaves us with x squared. Keep it in the square bracket for a minute because you haven't taken it out, so you haven't substituted and subtracted yet. Now we're going to substitute and subtract. So remember, we want to substitute the top limit first, so the 2 first. Now, you can stop using square brackets here now because we're actually substituting. Some people keep them, but you don't need them anymore. So I go to a curved here. So we're going to curved bracket, and we're going to substitute this 2 in. So we're going to have 2 squared, closey bracket. Remember, we subtract, and then we want to do exactly the same. We want to substitute our lower limit into where we have an x. So we're going to go 1 squared. Now, we normally keep our curved brackets around each of our limits because sometimes there can be more than one term. Obviously, for this one, we didn't really need it. So 2 squared, we do actually have to work out each bracket. Remember, you do have a calculator for it, but this one's a nice one. So 2 squared gives us 4. Take away 1 squared, which is 1. 4 take away 1 is 3. So the area under the curve is 3. You don't need to put units on the end, just leave it as a numerical answer. Question 2 then. So you can see you've got the integral with the limits 3 and 1, and we're integrating 1 plus 8x. So remember, you need your square brackets first, and we're going to integrate this. Remember what we said, when you have a number, you're adding a letter to it. So that's going to become 1x, or just x on its own. And this plus 8x is going to go plus 8x, increase the power and divide by it. Remember, square bracket to close, limits of 3 and 1 on the side. Cancel this down if you can. So square bracket open, we have our x. 8 divided by 2 here goes down to 4x squared. Close the square bracket, 3 and 1. Now we're going to substitute and subtract. So we're going to substitute the 3 in first. Remember, you substitute it everywhere where you have an x. So I'm going to open my curved bracket for my substitution of the 3. So it's going to be 3 plus, remember this means 4 times x squared. So 4 times 3 squared. There's my substitution of the 3. Then you subtract, and you're going to do exactly the same for the 1. So everywhere where you've got an x. So 1 plus 4 times 1 squared, and close that curved bracket. Now remember, you do have a calculator for additional maths, but what they do like to see is you working out each of these brackets. So type it in one by one. So if you type into your calculator 3 plus 4 times 3 squared, or you can work it out in your head if you want, because 3 squared is 9, times it by 4 gives you 36, add 3, 39. But if you have a calculator, why not use it? And then the 1 plus 4 times 1 squared gives you 5. So you have 39, take away 5, which gives you 34 as your final answer. Next one then, so you can see you've got the integral of 2 and minus 1, and then you've got a double bracket. So you've got 3x minus 1, x plus 1. So the first thing we want to do here, don't put your square brackets down straight away. We're going to need to expand this double bracket. So remember, so keep your integral here, the 2 and the minus 1, and we're going to expand this double bracket. So 3x times x gives us 3x squared. 3x times 1 gives us 3x. And remember, it's minus 1 times x to give us minus x, and minus 1 times 1 to give you minus 1 dx. Simplify it, so collect these middle terms first. So remember, we haven't integrated yet, so keep your integral there. So keep your 3x squared. We've got 3x minus x, so it's like 3 take away 1, which is 2. So plus 2x minus 1 dx. Now we're going to do our square brackets. So square brackets down and integrate. So we've got 3x, increase the power to a 3 and divide by it. Next term, so you've got plus 2x, increase the power and divide by it. And remember, a number on its own, you need to add a letter to it. Close that square bracket and then limits on. We need to cancel this down now. So 3 divided by 3 gives us 1, so it goes down to x cubed. 2 divided by 2 also gives us 1, so plus x squared minus x. Close your square bracket, 2 minus 1. Now I'm at the point to substitute and subtract, so we need to put 2 in first everywhere where you have an x. So I'm going to change to a curved bracket. So we have 2 cubed plus 2 squared minus 2. Subtract, and then remember, with a negative value, you want to put a bracket around it every time you put that minus 1 in. So I'm going to put minus 1 in a bracket cubed, plus minus 1 in a bracket squared, take away minus 1, and then close that bracket on the outside. Now when you type it in to your calculator, each bracket at a time, so when I mean each bracket, I want you to type in this part first, and then we type in this part after. Okay, so we're going to do 2 cubed plus 2 squared, take away 2 into our calculators, and it gives us 10. Keep the take away, and then here you want to type in the bracket, minus 1 cubed, plus the bracket with a minus 1 squared, minus the bracket minus 1. So everywhere where you see it, it should look exactly like that in your calculator display. And that bracket should come out as 1. So it gives you 10 take away 1, which equals 9. Example 4 then. So you can see we have the integral with the limits 3 and 1, and we have 1 over x squared dx. So we can't integrate this straight away because we don't know how to integrate a fraction, but we can write it in a different way. So remember, a fraction can be written with a negative indice. So we're not writing our square brackets down yet. So we're putting our integral with our limits on. And remember, this x squared can be written as x to the minus 2 dx. So a fraction can be written as a negative indice. Now we can integrate it. So square brackets down. So x, increase the power by 1. So minus 2 added on 1 is going to be minus 1 over minus 1, limits on our square bracket. This can be simplified a little bit as we don't like minus 1 on the bottom of the fraction. So the minus can come up to the side and then the 1 doesn't need to be written as it's on the bottom of the fraction. So it can be written as minus x to the minus 1, limits on the side. So this minus 1 indice, there's two ways where you can write this into your calculator. You can either use the button where you can write any power in and you can just type in minus 1, or there is an actual minus 1 power button, which is your reciprocal button on your calculator, which is shown as x to the minus 1. So you could just press that button for a minus 1 power. You can also write it as minus 1 over x if you want to, but as we're just typing it into our calculator, I think it's easiest to leave it like this. So substitute and subtract now. So we're going to have minus 3 to the minus 1 in one bracket, and then take away minus 1 to the minus 1 in the other bracket. So I just want you to type this in exactly as it is in your calculator. So minus 3 to the minus 1, and that should come out as minus 1 over 3. And then keep your minus there, and then this bracket here, so minus 1 to the power of minus 1, should come out as minus 1. So minus a third minus minus 1, you can see this is going to turn into a plus, but you can just type this whole line into your calculator again, should give you a final answer of 2/3. Final example today then, so you can see this one's a bit longer because, like we said, integration can be shown as the area underneath a curve. So here it says the diagram shows a sketch of y equals minus x squared plus 2x plus 3. And you can see they've given you a sketch, and this is the curve that they've just said, and it's hitting the x-axis on 3 and on minus 1. Showing all your work in, calculate the area of the region bounded by the curve y equals minus x squared plus 2x plus 3 and the x-axis. So this 3 and the minus 1 here are your a and b, they're your limits. And because you're working out the area of the region bounded by the curve and the x-axis, you need to know to integrate. It doesn't tell you because you get a mark for knowing to integrate. So the first thing that you'd need to write down is the integral sign. Remember, your limits are the numbers on the x-axis, so the 3 because it's the bigger one on the top and the minus 1 on the bottom. And then this is your function. Don't write the y equals, just the x part. So minus x squared plus 2x plus 3 dx. And this is then exactly the same as the previous questions that we've done. You want to integrate it, put it in those square brackets, substitute and subtract, and get a final answer. So I'm going to turn over so I've got enough space for these workings. So remember, we had the integral of 3 to minus 1, and the equation was minus x squared plus 2x plus 3 dx. So we can integrate straight away here now. So square brackets down. Be careful on this one. The squared is here. That's just a minus in front of it. So keep the minus in front, increase the power and divide. So we're going to have x cubed over 3. Again, plus 2, increase the power, so it's going to go up to a squared, and divide by it. Number on its own, so remember we need to add an x to it. So this one's going to be plus 3x. Close your square brackets, limits on the side. Look to see if you can cancel anywhere, and here we can simplify this one down. So the first term is going to stay exactly the same, minus x cubed over 3, plus just x squared now, as 2 divided by 2 is 1, and then plus 3x. Keep your limits on the side of the square bracket. Now we can substitute and subtract. So we're going to be substituting our 3 in first. Take your time because we don't want to make any mistakes. So we're going to have minus 3 cubed over 3 plus 3 squared plus, and then remember, 3 times 3. There's your first bracket. Subtract, and then this is the more difficult one because it's a negative limit. So this minus 1. So everywhere where you write this minus 1, you want to put a bracket around it. So you're going to have minus, bracket around the minus 1, cubed over 3, plus, bracket around the minus 1, squared, plus 3 times minus 1. Close the bracket. Okay, so now we want to type this in. So again, you don't need to worry about the big curved brackets around the outside. You're going to type all of this into your calculator exactly as it looks here. So you're going to have your fraction button first. Make sure you have your powers where they are here. So minus 3 cubed over 3 plus 3 squared plus 3 times 3. And when you type that into your calculator, it should come out as 9. Take away. And then, again, you want to type all of this in here. So all of this part without the big brackets on the outside. So you're going to have minus, bracket, minus 1 bracket cubed over 3 plus bracket minus 1 bracket squared plus 3 times bracket minus 1. So exactly as you see there, and it should come out as minus 5 over 3. So again, you have a minus and a minus, which makes a plus. So it's 9 plus 5/3, but you can just type this line into your calculator, and it gives you 32 over 3. Now, if you want to change this to a mixed number, you can, but any equivalent answer of this is accepted. So 32 over 3, but if you want to change it to a mixed number of 10 and 2/3, you can.